Okay, students, so these are your notes of the work of energy and power. So, first thing is the work. When is the work is said to be done? So, work is said to be done whenever a force acted on a body. Whenever there is a force, let's say there is a body, and whenever there is a force acted on a body, and the body moves through some distance, and if this body moves some distance, let's say distance x, some distance in the direction of the force, and the body moves in the direction of force. Direction of force means what? Means the direction of force is like in the x direction. So if the body moves in the same direction, if the body moves in y direction, then there is no work done, because we know then the angle will become 90 degree. So in the direction of force means when the body moves in the x direction. If the force in x direction, then the body has to move in x direction, either in positive x or either in negative x. If the force in y direction, then the body has to move in the y direction, either in positive y or either in negative y. It can be moved in both, either in this direction or either in this direction. But the body has to move in the y direction. If the body moves in x direction because of this force, then angle will become 90 degree, and we know that cos 90 is 0, so our work done will become 0 in such cases. So that is the definition of work. So this work is done on a body only if the following two conditions are satisfied. First is what? First is a force act on a body. Okay, so the force must be needed, because we know the formula of work done, that work done is equals to F cos theta into D. So because force, there is no work done. So when first condition is the force acted on a body. Second condition is point of application of the force move in the direction of the force. So the point of application of the force moves in the direction of the force. So point of application is the same like the object. It is talking about the object. So point of application means on the object, whenever the force is acted, that is called as the point of application. Point of application. So point of application, or either the object or the body moves in the direction of the force, then only we can say that the work is done. If you want an example, so work is done when a horse pull a cart. So horse pull a cart. Okay. So let's say there is a horse and horse is pulling a cart. So to pull a cart, horse has to apply a force into this x direction. So therefore, cart is also moving in the x direction. Therefore, we can say there is a force and there is a displacement, or there is a movement in the body. Okay, and the body moves, or in the and the body moves in the direction of the force itself. Therefore, we can say that in such cases the force is done. Second case is like the engine pulls a train. Then there also force, and the body moves in the direction of the force, and then the man goes up a hill. So they are the examples where work is done. Next thing is work done by a constant force. So let's consider that the force is constant. So what is the work done because of the constant force? So we know the formula. So what is they ask? They ask how is the work done measured when the force acted along the direction of motion of the body. So when the force acted, okay. So there are two conditions. How we measure the work done when the force acted along the direction of the motion. So when the force acted along the direction of the motion means the direction of motion and the direction of force acted both are the same. And second, when the force acted, force is inclined to the direction of the motion of the body. So first thing we consider that the measurement of work done when the force acted along the direction of the motion. So this is the direction of the motion in the positive x direction, and the force is also acting in the same direction. So what happened? How we calculate this work done? We know this work done we calculate by directly. Our formula is like F cos theta into D. Here they take displacement as S. So we know if the directions are same, the direction of movement of body, and the direction of force, if they both are same, so angle will become 0, and we know cos 0 is equals to 1. So we know work done will become just the product of force and displacement. So here the force is F and the displacement is S. So here force is constant, therefore it becomes the product of force and displacement. So this is the case when the force acted along the direction of motion. Okay, so here it is written, when a force F vector displaces a body through a distance parallel to the line of action of the force. So when the force displaces a body parallel to the line of action of force, what do you mean by line of action? Line of action, like when we apply the force, so this is called, this total, this direction is called as a line of action of force. So this is the line of action of force, line of action of force. So it is called that if the force displaces a body through a distance, and this distance is parallel to the line of action of the body. So whatever the distance, like it can be either this side or either this side, the distance is parallel to the this line of action of body. They both are the parallel. This is the distance and this is the line of action. They both are the parallel, okay, in the and in the direction or in the direction of the force. So then we can use this formula. Work will become force into displacement. The product of force and distance move in the direction of force. So this become our work done. Next thing, the measurement of work done when the force and displacement are inclined to each other. So what happened? Let's say we are applying force in this direction. So this is the direction of our force. This is the direction of force, and the motion is in this direction. You can see this is the displacement of the force. So we have to consider work only because of the uh, when we said the work is done, we know two condition. When the force is acted, it must be force, and second, the body moves in the direction of force. Body moves in the direction of force. These two conditions must be satisfied. So what we do, we make some component of this force. So if we take the horizontal component, we know this horizontal components, this because of this theta, this component will become F cos theta, and this vertical component will become F sin theta. But we know because of this F sin theta, there is no its direction is like this, it is in y direction, and we know there is no movement of body in the y direction. So because of this force, there is no work done, we can't say, because we know for the work done there are two conditions must be set. First is force. So force is set, force is here, so first condition is satisfied, but the body moves in the direction, and the second is body moves in the direction of force. So but here its direction is y, either it can be positive or negative y, but body moves in the x direction. You can see the body is moving in the x direction. So therefore it doesn't follow the second condition. But if we look at this force F cos theta, so this follows the both condition. The body also moves in the direction of the force, and there is a force also exists. So in such cases, what we do, same thing, work done become force into displacement. So component of force in the direction of displacement. So we have to take the component, and we have to take the component of force in the direction of so this is the direction of displacement. This